Good morning, students. In the last class we discussed about using of concurrent signal assignment statement, how we can able to write a program in data flow description style. So that's what we discussed in the last class. And next, so in that concurrent signal assignment statement itself, so one more model is there. Okay, so that is conditional form of the concurrent signal assignment state. Okay, so the main difference between the previous one and this one is, if you look at this particular one, so while coming for that, so on the right hand side it has expression. So by means of evaluating that, so we got a value, and that particular value, so we are supposed to assign to left hand side signal name without verifying any condition. So whatever value we got, so that must be assigned to signal name without verifying any conditions. Okay, but while coming for the second model, so which is conditional form of the concurrent signal assignment statement. That is the second model in that particular one, conditional form. Where the main difference is, here it is not going to verify any condition, directly whatever value it gets, so that will be assigned to left side signal. While coming for this, by means of verifying the condition. Okay, so here we are going to get by means of using this particular when and else. Okay, so we are going to verify those conditions, and if that condition is satisfied, then only this expression value, so is going to assign to this particular signal name. Okay, so unlike previous one, here we are going to verify the condition. If it satisfies that particular condition, then only we are going to assign the expression value into that particular signal name. If that condition is not satisfied, then obviously at the else we are supposed to mention the another value, and that else value is going to assign to signal name. So that is what going to happen while in the case of second model within the concurrent signal assignment statement. Okay, so using of when and else keywords, so we can able to achieve that, and this is how the syntax seems to be for that. Okay, if you look at the syntax, so on the left hand side signal name same as previous one, and while coming for so less than or equals to, this is an assigning operator, this one also same as previous one, and right hand side first it consists of expression same as previous one, but from here, so all these are all additional to the previous one. Okay, so these are all when is a keyword, then Boolean expression you are supposed to write, where condition we are going to mention within by means of using that particular Boolean expression. Okay, then after that else is a keyword. So like that you can able to write multiple statements or single statements, so depending on our requirement. So because of that multiple statements they mention. So if only one statement is required, so then we can able to stop over here. This you can able to write. Okay, syntax for that particular conditional form of the concurrent signal assignment state. And while coming for this particular Boolean expression, so what it is actually, so Boolean expression combines Boolean terms using VHDL built-in operators such as and or not, NAND, etc. Okay, so Boolean expression combines Boolean terms by means of using the VHDL predefined operators such as and or not, etc. Okay, so that is what, and Boolean terms. So Boolean terms are the Boolean variables or results of the comparisons using the relational operators. Okay, so here I mentioned two technical words while looking for first Boolean expression. So where I mentioned Boolean expression combines the Boolean terms. So using VHDL predefined operators such as and or not, etc. and Boolean terms or the Boolean variables, or it may be results of the comparisons, so which we are performing using the relational operators. So those relational operators are seems to be like this. Okay, you are already aware of it. All these are all relational operators. Equals to, not equals to. Okay, backward slash equals to, that itself not equals to or inequality. And another relational operator is, okay, greater than or equals to, less than, and less than or equals to. Okay, So in that particular Boolean expression, so we are going to mention all this. So Boolean expression in general, so it combines Boolean terms. Okay, Boolean terms using predefined operators. Here we have in PHP predefined operators and, or, not, NAND, XOR, XNOR, all these. Okay, it combines all these Boolean terms using of those predefined operators, and while coming for that particular Boolean terms, where those are all the Boolean variables or results of comparisons which we are performing using the relational operators such as equals to, not equals to, greater than or equals to, less than, and less than or equals to. Okay, so this is what regarding that particular one. So the detailed explanation of that particular syntax, so which is a conditional form of the concurrent signal assignment statement. So that is how it seems to be. So this is what signal name less than or equals to expression. So when Boolean expression else, that is nothing but when this particular Boolean expression, so that condition becomes true, then this expression value will be assigned to signal name. If this condition fails, that means condition is false, then else value it is going to assign to that particular signal name. So that is what it is going to happen. So based upon the number of different values we are supposed to assign, based on the different conditions, multiple statements you can able to consider. And if you consider multiple statements, then so this is the syntax for that. Okay, so this is what the conditional form of the concurrent signal assignment statement. Compared to previous one, the main difference is here we are going to verify the condition. With respect to that condition only, so we are making sure that that expression value will be assigned to signal name or not. Okay, so because of that, this one also comes under so concurrent signal assignment itself, but this is the second model. First model is without verifying any condition, directly we are assigning right hand side value to the left hand side, okay, signal. But while coming for the second one, conditional form of the concurrent signal assignment statement, by means of verifying condition, then only we are assigning that particular expression value to signal name. Okay, so that is what the second model in concurrent signal assignment statement. Next, so we will look at so one program for that. Anyway, you are all aware of that that particular prime number detector. Okay, so prime number detector. If you look at that particular circuit, so you must remember this particular one. So because of considering the same example, so here we are going to describe all three description styles. So in that regard, you must remember all this particular circuit as well as all these signals, whatever names that we mentioned externally as well as internally. So initially it consists of N0 to N3, and after the first level crossing of inverters, N1 bar, N2 bar, N3 bar, and these we can able to indicate them as N3 underscore L in general. Okay. So as for our readability purpose, because of vertical bar you can't able to mention over there, so it seems to be difficult for typing. In that regard, N3 underscore L, while coming for N2 bar, N2 underscore L, while coming for N1 bar, N1 underscore L. These are all the notations we mentioned. And while coming for this N3 bar and with N0, this we mentioned it as N3L underscore N0. That signal name we gave in that particular program, such as like that. So because this bars representing seems to be complex, in that regard alternate name that I mentioned. So in the same way for this one, N3L underscore N2L underscore N1. Okay, so in the same way for remaining two as well. So these are all the signal output names of this particular AND gate, and finally F is the output of the 4 input OR gate. So this is the circuit once again that we are considering. So to write data flow description style by means of using the conditional form of the concurrent signal assignment statement. Okay, so remember this particular circuit. So now we are going to move on to that particular one. So program. Okay, wait. So this is how we can able to consider that particular one. Okay, so coming to this, so as I said previously, here also we didn't mention any entity declaration. Okay, here my intention is to write a data flow description style using of conditional form of the concurrent signal assignment statement. Okay, If that is the case, then once again I have to start with the library, package, then entity declaration part, after that architecture definition. But here, so straightforward I mentioned only architecture because of, so whatever description style we considered, all those are all going to differentiate with respect to architecture only. But representation of library, IEEE, okay, then after that package, std underscore logic underscore 1164, after that entity declaration. Entity declaration means within that we are going to describe only input and output, that's it. We are not going to mention any intermediate signals in that regard. So whatever the description style, for all of them, input and outputs are same. So because of that, entity declaration is same for all these three different description styles. In that regard, we are not concentrating on entity declaration and library and package declarations. So instead of that, all are going to differentiate at the architecture itself, that too especially in the architecture body. Depending on the type of concurrent statement that you are using, that we came to know whether that particular description is belongs to structural or data flow or behavior. So in that regard, our focus is mainly on architecture body. So for that reason, once again I considered architecture only. Okay. So but it doesn't mean that, so if you ask program for this one, you are supposed to write only architecture. Don't think like that. So you must start with library, then package, after that entity declaration, then only architecture definition must be present. Okay. While you are writing for exams, all these must be mentioned. So not only this particular one. Okay, remember it. Okay, anyway, here our intention is to write a data flow description style program, that too by means of using the conditional form of the concurrent signal assignment statement. We already saw the syntax for that. Signal name less than or equals to expression, when is a keyword, Boolean expression, and then else. Considering that particular one, so here we started the architecture. So architecture name of entity name is, then signal names. So anyway, so you can able to write these particular signal declaration statement after completion of this particular one, because so here whatever signals you considered, all these must be predefined. So whether these signals must be defined in entity declaration part or within the architecture, that too before the architecture body. Then if you look at this particular one, so this architecture body here I represented multiple concurrent statements, and whatever signals you consider, n of 3, n of naught. On the right hand side we considered n of 0, n of 1, n of 2. All these are all declared in entity declaration. While coming for the left hand side, so these are all the signal names that we mentioned. Actually we thought of AND gate output signal names itself we considered such as like that, where F is the output of the OR gate. Okay. So anyway, F is also predefined in entity declaration part, but if you look at this particular one, all these signals are not yet defined because of all these are all internal signals. So whatever signals not yet defined in this particular one, okay, those must be defined by means of using the signal declaration. So that too before the starting of the architecture body. Then once if you write this particular one, then it seems to be easy for you what all the signals are not covered and what are all those signals we are supposed to mention in signal declaration part. In that regard only I am saying that, so just leave one line, then begin, so architecture body, and whatever so assumptions that we are going to consider, those signal names and all. So after writing that particular one, whatever signals are not yet covered, those must be declared within that particular signal declaration. So that is the better exercise. So in that regard, so I mentioned after realizing this, then you are supposed to write the signal declaration. Okay? Anyway, so here we considered this is the program, architecture name of entity name, then is, then signal declaration began. So here also we considered we started at the second level, that is first level is inverter output and second level is AND gate outputs and last level is third level which is OR gate output. Okay, so this is the first 2 input AND gate output. We mentioned names such as like that, N3L underscore N0. Okay, so based on this syntax, in the same way we are supposed to write program for this. Okay, so if you look at this particular one, so signal name, we mentioned this one, less than or equals to, assigning operator. So on the right hand side, expression. So expression where it consists of this value. Okay, and if you look at that particular one, So before that, writing this particular one, you need to know the functionality of that particular circuit. So considering it, so N3 bar and N0, because of that is an AND gate. If these two are ones, then only output become 1. Okay. So if any of these two inputs is 0, then output is obviously 0. So because of that, what is the condition that we need to verify? Because of N3 bar, here it consists of. That means we are performing inverting on N3 input. Okay, not of N3. So because of that, N3 input must be 0. Then N3 bar become 1. And after that, N0. N0 is in true form, because of that N0 input must be 1. Okay, if that is the case, then N3 bar and with N0 become 1. For all remaining cases, if these two N3 bar and N0, if both are ones, then only this output become 1. For all remaining cases, these two input and gate output become 0. Because of 0, 0, 0, 1 and 1, 0. For those three combinations, output becomes 0 itself. Only for this particular one. That means N3 must be 0 must be applied. N3 0 means then N3 bar become 1. So N0 and with. So N0 must be 1. So N3 0, N0 0 if you apply, okay, N0 1 if you applied. So at that time only output become 1. For all remaining cases, output will be 0 itself. In the same way for remaining as well. So N3 bar and with N2 bar and with N1. So because of this is a 3 input AND gate, N3 if you applied 0, then N3 bar become 1. And with N2 if you applied 0, then N2 bar become 1. And N1 is in true form, because of that 1 we are supposed to apply. Okay. So because of that 0, 0, 1. So 0 at N3, 0 at N2 and 1 at N1 if you apply, for that particular input combination only this output become 1. For all remaining cases, output of this particular 3 input AND gate is 0. Okay. So that is the condition we are supposed to mention over there. In the same way for this one. N2 bar. So if you apply 0, then N2 bar become 1. N1, true form, 1, N1, 1. Then only it become 1. So that is the condition. So 0, 1, 1 you are supposed to apply. In the same way for last one as well. Okay. So remember this. While coming for first one, you are supposed to apply the combination 0 and 1. Okay, while coming for second one, you are supposed to apply the input combination 0, 0, 1. So in a descending order from N3 to N1, like that. So while coming for this particular one, 0, 1, 1. And while coming for this, 1, 0 and 1. So that is the combination we are supposed to apply. Okay. So remember this particular one. Anyway, first one is N3 must be 0 and N0 must be 1. Okay. So considering that, so go to that particular program. So now look at this. So we are supposed to assign value 1 to the 2 input AND gate output signal N3L underscore N0. So when we are supposed to assign that particular one, if N3 is equals to 0. And in addition to that, one more condition it needs to satisfy. Because of that, we used built-in operator which is AND. N of 0 must be equals to 1, because of the equation is N3 bar and with N0. So N3 must be 0 and N0 must be 1. If we got these two are the inputs, then if these two cases are true, then we are supposed to assign this particular 1 value to the N3L underscore N0. So if this condition is not satisfied, some other combinations other than 0, 1 remaining 3 combinations if I apply, then obviously else. Okay, so it moves to the else part, and whatever value we mentioned at the else part, so that value will be assigned to that particular signal. So that is how it is going to execute. Conditional form of the concurrent signal assignment statement. And as I mentioned in the previous syntax, this whole thing we can able to consider it as the Boolean expression. Okay, so signal name less than or equals to expression when Boolean expression. As I mentioned, Boolean expression. So what it consists of? Boolean expression combines the Boolean terms. So this is one Boolean term and this is the another Boolean term. Okay. combines the Boolean terms using the predefined operators such as and, or, not, and so on. So here the Boolean operator is and. So that's what I described initially. Okay. So Boolean expression combines Boolean terms. N3 equals to 0, N of 0 equals to 1. These two are the Boolean terms, and those two are combined by the using VHDL built-in operators such as and over here. Okay. Where Boolean terms are Boolean variables or results of the comparison using relational operators. So here we consider Boolean terms are results of the operations. Okay. Results of the comparisons. Okay. Using the relational operators. Here we consider the relational operator is equals to. Okay. So that is what? Based on this particular one, if this condition, whole Boolean expression becomes true. So how it is going to evaluate? N3 of 0. If that is true, then true it becomes. Then and with N of 0 equals to 1. If that condition satisfies, then it also true. Okay? Then true and with true. Result becomes true. If this Boolean expression becomes, because of Boolean variables are true and false. Those two only. Okay? So because of that, the result will be displayed either true or false. So if N3 is 0 and N0 is 0, then these two conditions become true, and true and with true it becomes true. Because of this whole Boolean expression becomes true, then this one value will be assigned to that particular signal. If any one is false or both are false, then obviously else value will be assigned to this particular signal. So that is what regarding this particular one. So in the same way, so remaining gates also we are supposed to write. Second, we consider the 3 input AND gate. Okay, so for that one is N3 bar and with N2 bar and with N1. That means N3 must be 0 and N2 must be 0 and N1 must be 1. Then only that particular AND gate output become 1. For all remaining cases, output is 0. So in that regard, so expression once again I considered 1. N3 is 0. Okay, N2 is 0 and N1 must be equals to 1. If these three are satisfied and all these three conditions is true, then only it assigned value 1 to this particular signal. So other than that, if any other three combinations that we are applied, then obviously it fails. By means of that, else value will be assigned to that particular signal. 0 will be assigned for all remaining combinations other than these three. So same as previous one. So this whole thing is a Boolean expression, where Boolean expression combines Boolean terms using the Boolean operators such as and, or, NAND, whatever it may be, depending on the requirement. So here I am using the AND gates only. In that regard, Boolean operator is built-in operator that we used is AND gate itself. So it consists of 3 Boolean terms. Okay, and in between I used the Boolean operator and, where Boolean terms are Boolean variables or results of the comparisons using the relational operators. Here also I used the relational operator which is equals to. So if this condition satisfies, then it becomes true. And if this condition satisfies, true. If this condition satisfies, that also true. Then in between true and true and true. So because of that, so this whole thing is true means then only this value will be assigned to this. If any condition fails, then else 0 value will be assigned to that particular one. In the same way, remaining 2 also you are supposed to represent. So N2 must be 0, N1 must be 1, N0 must be 1. For all those, for only for that particular case, 1 will be assigned. For all remaining 7 combinations, 0 will be assigned to that particular one. Next, so fourth 3 input AND gate which is, so N2 must be 1, N1 must be 0 and N0 must be 1. So if you got this particular combination, then only 1 will be assigned, otherwise 0 will be assigned to that particular one. And after that, so here we completed all the AND gates, second level AND gates, and last level is which is OR gate. Okay, output is F. So while coming for output F less than or equals to same as previous one. Okay, so OR operation we need to perform. Okay, so here I considered while you are writing for this particular one, I considered only first model of the concurrent signal assignment statement, that is, okay, signal name less than or equals to expression. So this is the expression. Okay, so if you want, you can also write based on this particular one, because of OR means so many ones that you are going to get, but while coming for AND gate, only for that particular one combination only you are going to get 1, for all remaining 0. So in that regard, it seems to be easy to write in first model of concurrent signal assignment statement. So because of that, for this particular one, he considered the first model itself. So anyway, in any order you can able to write. Only considering of the second model or first model or combination of first model and second model is also possible. So all these are all allowed in our VHDL. Okay. So and finally, after writing this particular one, so finally we are supposed to close that particular architecture. So with the architecture name prime3 underscore or whatever mentioned we have seen. So after completing of this particular one, now go for the signal declaration. So whatever signals are predefined, so neglecting them, so remaining signals, what are all not yet defined. So all these n of 0, n of 1, n of 2, n of 3, all these are all predefined and F also predefined in entity declaration part, but these signals are not yet defined. But we used those signals within the architecture body. In that regard, we must mention all these four, which are all not yet defined. All these four signals we are going to mention in the signal declaration part. So because of that, these four signals only we mentioned. By means of using the signal declaration syntax, starts with the keyword signal, then signal names, colon, signal type, which we consider it as st underscore logic. So that is how to represent the data flow description style by means of using the conditional form of the concurrent signal assignment statement. By verifying condition only, we are going to assign value for that. Okay. If the condition fails, else value we are going to assign to that particular signal name. Okay. So this is what regarding that particular one. Anyway, thank you very much.